Alright, this lesson is dealing with volumes of prisms and cylinders. So we're going to learn to apply the formula for the volume of a prism and a cylinder. Remember that volume is a three-dimensional figure with the number of non-overlapping unit cubes of a given size that will exactly fit inside the shape. Alright, and then this guy named Cavallari says that if two three-dimensional figures have the same height and the same cross-section area, then they're going to have the same volume. So something like this, where this would be a right triangular prism, this would be an oblique triangular prism, but because they have the same cross-sectional area, these little triangles in here, they're going to have the same volume. And so to find the volume of these things, we're going to use this formula right here. Volume is equal to the area of the base times the height of the prism. For a right triangular or right rectangular prism, it's just length times width times height, which you're used to. For a cube, it's going to be side cubed, side times side times side. So let's jump right into a problem and get this done. Volume is equal to length times width times height for this thing. So that is going to be 13 times 3 times 5. Which is going to come out to 195 centimeters cubed. Alright, for this next one, we're going to actually look at a hexagonal prism. Notice that it says right, meaning that these right here, these rectangles, or these faces are actually rectangles. Alright, so we need volume is equal to the area of the base times the height. So I need to figure out what my base is, the area of my base, and I need to know my height. The height of the prism is 12, so that's easy enough. So to solve for this, I actually need to find the area of the hexagon. Alright, so it says that each side, since it's a regular hexagon, that means all of these sides are 9. All the way around. But in order to find this base, actually what I'm going to end up having to use, my 1/2 apothem times the perimeter of the base. So I need to draw my apothem and my radius. And my radius then is going to be 9 because it's a hexagon. The radius and the sides are the same length. The apothem cuts the side in half, so that's 4.5. My A for my apothem. Okay, and I'm going to have to use, I can use Pythagorean Theorem, I can use special right triangles to find this out. I'm going to use Pythagorean Theorem. A squared plus 4.5 squared is equal to 9 squared. So my apothem is equal to 9 squared minus 4.5 squared, which is 60.75. Taking the square root of that, A is equal to the square root of 60.75, which comes out to be about 7.79. Right. So I'm not going to, I'm rounding it as far as notes purposes, but on my calculator I'm going to leave it, I'm not going to round it. I'm going to leave that as part of my my calculations. So then I would want, for the area of the base, now I know my apothem, my A is about 7.79. My perimeter then is going to be 9 times 6, which is 54. So when I put this in the calculator, I'm going to hit alpha, y equals 1/2. Now to get this, I'm going to hit second, and then I'm going to go down here to this negative button that says ANS on top. That's short for answer. So it carries this calculation. It doesn't round it. It carries this into this next problem times my perimeter, which is 54. Alright, so my 1/2 AP, that comes out to be 210.44. Again, I'm not going to round it. I'm going to leave that in my calculations when I do this. So now I have my volume is equal to this 210.44 times my height of 12. So again, it has this answer in the calculator. I'm just going to store that in there. I'm going to replace that times 12. So I'm not doing any rounding just yet. I want to round here at the very end. So the volume is going to equal, actually that's still an approximation, that's about 12,525.3 cubic feet. Okay, a lot of things we had to solve for. We had to find, in order to find the area of the base, I needed to calculate the apothem and the perimeter of the base, then the height of the prism when I substitute in for the volume. All right, number 3, I'm going to leave that one up to you to check with me to make sure you're doing this right and you understand how to use the volume formula. All right, let's do this next one. A swimming pool is a rectangular prism. Estimate the volume of the water in the pool in gallons when it is completely full. 1 gallon is about 1.34 cubic feet. The density of water is about 8.33 pounds per gallon. Estimate the weight of the water in pounds. Okay, so we got to find the volume of this swimming pool. It's a rectangular prism, so we have to find out what the volume is, and then we're going to have to use some conversions using this gallon. 1 gallon is about 0.134 cubic feet, and these pounds to get the actual weight of the water inside the pool. So first, let's start with the volume is equal to area of the base times height. Remember that for this, the base, since it's a rectangular prism, is just length times width. So really we're looking at length times width times height. So that's just going to be 25 times 15 times 9, which comes out to be 3,375 cubic feet. Alright, so I'm going to go ahead and convert this into gallons then. And I'm going to kind of set it up as a proportion, so I know 1 gallon is equal to 0.134 cubic feet. So then to find out how many gallons this is, I'll put that as an X over, what did we get, 3,375 cubic feet. So remember my ratios, and I would cross multiply, so I'd get 3,375 is equal to 0.134 times X. And then, so let's do that in the calculator. When I cross multiply, I would have to divide here. That gives me that X is going to be 25186.567. We go to the nearest thousandth. And then the density of water is about 8.33 pounds per gallon. So this is how many gallons it would be. That's 25,186 gallons. So I'm going to take that times 8.33, and we get that this would be 209,804. Estimate the weight. Let's go ahead and go to the nearest pound. 209,804 pounds of water is what that would be. All right, next we got that Cavallari's Principle, also related to cylinders. And this kind of shows a better picture. If this was a right cylinder, I can take these cylinders, these CDs, and I can kind of slant them this way. And this volume here would be the exact same volume of this, because it's still the same number of CDs. It's just slanted. So that gives us this. The volume of a cylinder with base area B and radius R and height H is still area of the base times the height, which is going to be pi r squared H. Okay, so let's look at this example here. Volume is going to be equal to pi r squared H. My radius is going to be 9. My height is 14, so we got pi times 9 squared times 14. It does say round to the nearest tenth. Putting that in the calculator, that's going to come out to about 3,562.6 cubic inches. All right, and let's see, number 6. I'm going to leave that one up for you to solve. Alright, this next example has to do with dimensional change. we kind of talked about this before with perimeter and area. Now we're going to look at it in terms of volume. So the radius and the height are multiplied by 2/3. So remember that if we're just changing one of the dimensions, then the scale factor, this would be my scale factor, that would just be, I would take whatever the perimeter and multiply that by 2/3 to get my new perimeter. Now if I'm talking about area, then I would square it times I would square my scale factor times my area. So with volume, I'm going to actually cube it, take it to the third power, times my original volume. So for this, I'm going to go ahead and calculate the original volume. So I have pi r squared times h. So this is going to be 24 squared times 33 pi. So 24 squared times 33 comes out to be 19008 pi. That's my original volume. When I want to change the radius and height by a scale factor of 2/3, I'm going to take this and multiply that by 2/3. But because it's volume, I have to take it to the third power. So perimeter is to the first power, area is to the second power, volume is to the cubic power. So let's put that in the calculator. And the new volume, if I kind of round this out, would be 17,693.45 inches cubed. But it does say just describe the effect on the volume. So the effect would be that it changes by 2/3 to the third power, which is going to be 8/27. If I cube this, changes by a factor of 8/27. Alright, this next one says find the volume of the composite figure. So what I'm going to need to do is I'm going to need to find the volume of this rectangular prism on the bottom plus the volume of this triangular prism on top. So for both of these, since they're both prisms, I'm going to use area of the base times the height. For this rectangular prism, so the volume of the rectangle, that's going to be 5 times 4 times 8, which comes out to be 160 cubic centimeters. The volume of the triangle is going to be a little harder because I have to find out the height of the triangle. So there's going to be kind of an extra step because my B is going to be 1/2 base times height. I know my base is 8. I need to use, I can use Pythagorean Theorem, or I can use my special right triangles and come up with a height of 4 square roots of 3. So my base is going to be 16 square roots of 3 for this triangle here. So I have 16 square roots of 3 for my B times this length right here is going to be my height of 4. So that comes out to be 64 square roots of 3. All right, but it says round to the nearest tenth, and again, we always want to round at the end, so it's going to be 160 plus 64 square roots of 3 is my composite volume. So let's put this in the calculator right quick. 160 plus 64 square roots of 3 is going to come out to be rounded to 270.9 cubic centimeters. All right, number 9, I'm going to have to leave that one up to you to solve. If you want the answer, check that with me in class. All right, I'll give you a hint on this one though. This one's going to be volume of the cylinder minus the volume of the prism. All right, so you'll need to calculate the volume of the cylinder minus, you want to take out this, I guess it would be a square prism actually. You'd want to take this out of the cylinder.